Okay, please read question and then I will show you answer and then I will explain to you. So first of all, read question, try to understand. If you have any question, you don't know what question is asking you, you can also ask me. I will explain to you question as well. Okay, so this is the first stage. You need to read question. So you are reading question now. At this moment, you are reading question now. Okay, so I hope you have answered and you have also read this question. So let me show you the answers now and then I will explain to you. Okay, here please. So here are the answers. So you can see here. So these are the answers for you now. So these are the answers. So you see the first thing question was asking you what is meant by diffraction of a wave. So diffraction of the wave simply means that if we have this obstacle, for example, we have this gap and these waves are coming, you have these waves, they are coming. So when these waves, they will pass through this gap, they will spread out. They will spread out like this. So let me draw this one little closer. So we need to understand in this case is that you see, this is the gap between these waves. This is the wavelength. This is the lambda. So the here lambda also has to be the same. Means this has to be the same, equal to this one. So this is little far, but let me draw a little bit closer. So you see, this has to be this much here. So this gap you need to understand. This wavelength has to be the same. So like this, you can draw. And the next one also has to be the same. So the wavelength, so we will also draw like this. So this is called diffraction of a wave, means the spreading out of the wave. So you see this wave is, if you look at this wave, is here, is this part. Wave is here. So after that, you can see here the wave spread out. So the wave spread out, you can see the wave spread this way. Actually, this is here. So if you draw the line here, you can also see like this. You see the wave spread out. So this is the spreading. So this phenomenon we call is diffraction of a wave. So you need to keep this in your mind. Most of the time, this has 2 marks actually. So this is how you can define spreading out of waves after passing through a gap. This is a gap or around an obstacle. So it's also, for example, if the waves are here, this is an obstacle, for example. So if these waves are coming, so you can also see if these waves are coming after passing through this one, they will spread like this. So they will be like this. You see, they can go beyond, behind the obstacle. So this is the obstacle in front of waves. So this is obstacle. So they can go behind. You see, they are spreading this way. So this is. Okay, so this is what we need to understand is what is diffraction. So this is you need to be able to define. So this is how we can define actually what is diffraction. So the next thing we need to understand, the next part was asking us if you look at this one, we have a bright fringe at the center, then we have a dark fringe, then again we have a dark fringe. So here, the next one again will be a bright fringe. So I will write down here, here is an other bright fringe. So here is an other bright fringe. Now the question is asking us why we have this bright fringe at this point. Means why this bright fringe is formed here. Bright fringe. So how we can understand this one? To understand this one, we have to start from here. So if the waves go from this point to this point, and the waves go from this point to this point, you can see from here. So the distance covered by, I can say we have, let's say this is wave A, let's say this is wave B. They cover the same distance. So if they cover the same distance, we can understand now here. If we have one wave like this, you can see this is one wave. And if we have another wave and we add these two waves, so what we will get? We will get a very big wave. So we will get a very big wave. Because these two waves, you can see it has its maximum amplitude here. So we call these two waves, they are in phase. So they are in phase. So if they are in phase, we can add them. You see this amplitude plus this one, we got the bigger amplitude. And this is minus amplitude, negative displacement, we add, we get more negative. So this is in phase. So, and this also we call is constructive interference. So this is called constructive interference. So here this is called constructive interference. The second thing is that, now let's say we have one wave like this, and other wave is just in antiphase like this. So is like this. So this one little draw in a better way. So we can draw like this. We can say it is like this. Now you see this has positive amplitude, this has negative, so they will cancel each other. If we add these two waves, we call them, they are antiphase, or we call sometimes out of phase. So these two waves are antiphase. So if we add them together, we will get nothing. So we will get no light. So we call this is dark fringe. So this will be dark fringe, means no light. Dark fringe simply means that lack of light. And this interference we call, this is destructive interference. So I'm just writing all the points for you to understand. So this is called destructive interference. So you can see here, this is destructive interference. Now, and this one we call, this is bright fringe. So this one is bright fringe. So the bright fringe is formed when these two waves are in phase. So first thing, these two waves has to be in phase, and we call the path difference has to be 0. Means there is no difference in distance they cover. So the path difference has to be 0. Okay, path difference has to be 0. So you can see from here, the wave travel from here, go to this point, and wave travel from here, from this slit, go to this one. They cover the same distance. So the path difference is equal to 0. It means this is constructive interference. If it is constructive interference, it will form bright fringe. Okay, so these are the points you need to understand. Now let's go and try to understand for me how to answer this one. Waves from slits overlap at point X. Means the waves from this slit and this slit, they meet at this point. Overlap means they meet. Path difference between waves is 0. It is 0 because they cover the same distance. And the bright fringes are formed due to constructive interference at X. This is what I explained to you here. So this one you have to keep in your mind. They will ask you many times in exam. This is a very common question. Okay, so please, any question about this one now? Is it clear to you? So this is how we can answer. If you have any questions, please type and I will explain to you. Otherwise, write down these answers, please. Write down these answers. So this is what you need to understand. Okay, excellent. If it is clear, so please just write down these points. If you have written, just write down finish. So I will go to next one. Otherwise, you can take notes and you can write the points from here. Okay, so when you finish, just type finished. So I will go to next one. Okay, excellent. Kiki, excellent. So, okay, excellent. Okay, excellent, Steven. Excellent. Okay, nice, nice. So, and also please, if you want to watch these videos again after class, you can also download from the group actually. If you couldn't find in the group, you can send me message. I will send to you this one. Okay, so let's go to next one now, if you have finished. Okay, so let's go to next one. Okay, so next one, please. I will move on to next one now, if you have finished. Jim, Evelyn, have you finished? Okay, excellent. So let's move on to next one now. Okay, that's good. If you took the picture, that's good. So later you can write down. That's also one way. Okay, so next one, please. Okay, so the next question we have. Here is next one. Now, next question, please, is a very simple question. There is a one key point you need to understand. So if you understood that key point, this question is very straightforward. So let me first of all, again, we will follow the same steps. First step, read question. So the first stage is you have to read question first by yourself. So please read question. First of all, read this question. So this is our first step. So read question first of all again now. So the second stage will be, I will show you the answer. So we are working on first stage now. So this is first stage. So you have 2 minutes, read this one and look at this diagram. Then I will show you answer and then I will explain to you. Take time and read question first. Okay, so next stage is now I need to show you the answer. So let me show you the answer and then I will explain to you this one. So here please, this is the answer for first one. So how we got this answer? So now for this one we need to understand is that you have to look at this one. You see we have a bright fringe at the center. Then we have a dark fringe here. Okay. Slit to point Y. So is here. And also here will be an other bright fringe. So the next one here will be an other bright fringe. So this will be an other bright fringe. Now, how we can understand this one? So to understand this one, if the ray of light, for example, we have seen if it travel from here to here, so we have seen that one, the path difference for this one. For the first one, we have seen that the path difference is equal to 0. This is what we have done in the previous one. The path difference is equal to 0. Okay. Now, the question is asking you, state the difference in the distance from each slit to point Y. So let me use different color. Now, if the ray of light start from here, go to, so this is very important point. If you understood today, it means that you can use it whole life. This is the one concept. You see, if the ray of light travel from this slit to point Y and one ray of light, it travel from this point to Y. So in this case, you can see here, we have a dark fringe. Dark fringe is formed if lambda, the path difference, is equal to lambda by 2. The path difference is equal to lambda by 2. The path difference is equal to lambda by 2. And this is also true. You see, we have dark fringe here. So in this case, path difference also has to be equal to lambda by 2. So the path difference has to be equal to lambda by 2. So if light travel from here, reach this point, and travel from here and reach this point. So if this distance is d, distance will be equal to d plus lambda by 2. So the difference between distance will be equal to lambda by 2. So you see the lambda is given to you. You just need to divide by 2. So we got this answer. That's all. Because lambda is in nanometers, so this also has to be in nanometers. Okay, so this is, please, you need to understand all the time. Remember, so this is for this question. I can generalize this one so you will remember more. So is this point is clear? Okay, so if this point is clear, let me write down in a little different way. So that is what you can remember and you can use again and again that same concept. So here, let me write down the journal form for you here. So the journal form is like this. Journal form is like this. you have one bright fringe at the center bright fringe. The path difference always has to be equal to 0. The path difference is equal to 0. And for the next bright fringe, this is the next bright fringe. So for this one, this is also an other bright fringe, the next one. So this is bright fringe. For this one, the path difference has to be equal to 1 lambda. 1 lambda has to be equal to 1 lambda. And for this one, it has to be equal to lambda by 2. And if there is next, for example, bright fringe here is an other bright fringe. Let's say I will say there is an other bright fringe. For that bright fringe, the path difference has to be equal to 2 lambda. Has to be equal to 2 lambda. And so on. So like this, for bright fringes, you just add 1 lambdas. At the center bright fringe, path difference is equal to 0. For the next bright fringe is equal to 1 lambda. For the next one, 2 lambda. For the next one, 3 lambda. And so on. Above and so on below is true. That's all. And the dark fringes, this is lambda by 2. And the next dark fringe will be here. So for that dark fringe, that will be 1.5 lambda. So you see you have lambda by 2 plus 1 lambda. If you add, you will get 1.5 lambda. So like this, you can find path difference. How to remember this one? So the way, for example, this one you see lambda is equal to here. Here you can see now the path difference, for example, for this one is equal to 0. For the first bright fringe, center bright fringe, path difference is 0. How about the next bright fringe? Path difference is equal to 1 lambda. How about the next bright fringe? Is equal to 2 lambda. That's all. Start from 0, then go to lambda, and then go to 2 lambda, 3 lambda, 4 lambda, and so on. So it's like this here. So I can draw a line here for you. Let me write down a little bit more number. Let's say this is the center bright fringe. I will say this is center bright fringe. So for this one, we say n is equal to 0. This is the center bright fringe. If you want me to write down in a detail, so I will say this is center bright fringe. Often we write down like this one. This is the next bright fringe. Next bright fringe. For this one, we will say n is equal to 1. And for the next bright fringe, you can say n is equal to 2. So n is equal to 1 means that 1 lambda. N is equal to 2 means 2 lambda. If here is n is third bright fringe, n is equal to 3. So this is 3 lambda. That's all. 0, 1, 2, 3. This is for bright fringes. And then if you need to write down for the dark fringes, let's say at the center, this is a dark fringe. So this is dark fringe. So let me write down here, this is for dark fringe. Okay, for dark fringe, this will be lambda by 2. Excellent. So this will be 1.5 lambda, 2.5 and so on. So this is the order you need to understand. That's all. Okay, we will do more questions. You will be very clear. If you got now, that's wonderful. Okay, let's go to next one now. So this is how we can answer this question. Okay, so the next one is asking you, excellent, so that's all. This is for dark fringe and so on. Wonderful. So this will be for dark fringes. Wonderful. So that's right. That's right. And for bright fringes will be 0, 1, 2, 3. That's all. Excellent. So this is how you can find. Now please, the next thing, calculate the distance d now. We need to find this distance. We have to find this distance. So how we can find this distance? So let me first of all clean this one and I will write down again for you. So I will just clean this one. Okay. So for this one, let me clean first of all. Okay, now you can see here, we need to find this distance. So few things we need to understand. The distance between Okay, first thing, let me ask you one thing, otherwise you will be a little confused. So, what is this? What is this hole actually? Actually, this is a hole like this. This is a hole. So, you are looking from one side. This is a side view of the hole. So, this one we call is a slit. This hole is called slit. So, you need to understand the name of this one. So, this is called slit. So, this is one slit. This is an other slit. This is also hole actually. So it's a side view. So you see like this. So this is another hole. So we call this is slit, another slit. Okay. So these are two slits. So between these two slits now, so these holes we call them slits, and the distance between two slits. Let's say distance from here to here, from center of one slit to center of another slit. Let's say this distance is equal to D. Let's say this distance is equal to D. So we can write down this distance is equal to D. Okay. Now, we see here we have center bright fringe, and here let's say we have next bright fringe. So I will say this is an other bright fringe. So this is another bright fringe. This is an other bright fringe. So I will simply say, in this case, the distance from one bright fringe to next bright fringe means from this one. So this distance we call fringe spacing. So let's say this distance is equal to x. So what I have explained to you is that D is called slit separation from the center of one slit to the center of next slit. So we call slit separation. Now the next thing, x. What is x? X is called fringe spacing. So x is called fringe spacing, means the space between two bright fringes. So you see we have the one bright fringe here and the next bright fringe. The distance between two consecutive bright fringes is called fringe spacing, and this is x. Okay. Now, and this is D. Now the question is that how A, how X, how D and lambda, they are connected, how they are linked together. So what is relationship between them? So the relationship is very straightforward. So in this experiment, we are talking about double slit experiment. So you have to be very clear about this one. So I'm talking about double slit experiment because we have two slits here. So this is called double slit experiment. So you also need to understand the name of this experiment. This is called double slit experiment. So now we need to figure out how these variables, they are linked together. So it's a very simple one. So they are linked together by AX. If we multiply them, they are equal to lambda times D. Okay, so they are linked together. Now the question is asking you, you need to find the distance D. So I can rearrange this formula. I can write down that this is AX over lambda here. So I will just simply write down like this. Now, the next thing what we need to understand is, we need to understand what is D. D is given to you. In this case, I wrote A, so this is D actually. So I have to be consistent. So sometimes we use A, sometimes we use D. So this is the D. So D you see is equal to 0.41 mm. So you have to be very careful with unit. So this is mm. So I will convert into meters. So this is into meters. So I have converted into meters. Now X is the fringe spacing. Now you can see here it is given to us 2 mm, but this is from bright fringe to dark fringe, but we need to find from one bright fringe to an other bright fringe. So we have to multiply this by 2 because this is half, so it has to be double. So in this case you will say 2 times 10 to minus So it has to be 10 to minus, this is in millimeters here. So do you know why I multiply by 2? Because this is half. That's reason you have to multiply this one by 2. Okay, so is this point is clear? Why I multiply by 2? Okay, so if that point is clear to you, so let's go and try to answer this one now. Okay, next one please. Lambda, you see the wavelength we have here. This is given to us, but this is in nanometers. So we have to write down here 580 times 10 to minus 9. Now what we need to do is we just need to use simple mathematics and we will find our answer. Okay, so we just need to multiply and divide, we will get answer. So any question until now? Please, if you have any question, just ask me. No, only 580. This is lambda is 580 here, please. Lambda is only 580, that's all. Okay, so not divided by 2. Okay, so we have to use value of lambda here. So lambda given is 580, not divided by 2. So it has to be 580 nm. Okay, so this is how we can answer. It is not divided by 2. Okay, so let me write down here lambda for you. So the lambda is equal to 580 nanometers. So this is. Okay, now please, if you understood this point, is wonderful. So let me show you the answer now. If you use mathematics, just use calculator, you will get the answer. So if we solve this one, this is our answer, 2.8. If we solve this one, we will get 2.8. So our answer is 2.8 meters. So this is how we can find answer. Okay, this one please. So this is how we can answer. So if this point is clear to you, how to answer this one. So next time if you need to answer, you have to follow these steps. Okay, so shall we go to next one now? You can write down this one now. You can write down this one. So then we will go to next one. Okay, so please let me know when you finish. I will go to next one. Okay, excellent, excellent. So let's move on to next one now. Okay, if you are still writing, you can take photo and you can write later by yourself. So let's move on to next one now. Okay, here. So here is the next question. So the first step, what we need to do is you have to read question, please. So again, we have to follow 3 steps. First step, read question. So you have to read question now. First of all, please read question. So this is first stage. Read question by yourself. And so only read this one. So then we go to next one. So first read only question about waves. Okay, Jim, you can go quickly, go and come back. Okay, please read question and try to answer by yourself. First of all, try by yourself. Okay, so the second stage now is the second stage. So the second stage, I need to show you the answer and then I will explain to you. So here is our answer. Okay, here please. So let me clean this one and then I will explain explanation. The third stage is explanation. So now please read these answers now. Do you understand why the answer is like this? So I will divide this one into two parts. I will divide this one into two parts. Here I will explain. So first of all, okay, first stage please. We have one wave like this and we have another wave. So this is what we have seen in the previous case. If these two waves are in phase and they have the same amplitude. So here you need to understand these two waves are in phase. And excellent. Okay, Jim, excellent. Now I'm explaining this question now. So you can see if the waves are in phase and have same amplitude, if they are in phase and they have same amplitude, what will happen? So you will have a super crest here like this. You see, we will add them, we will get this one. So this is what we have called this kind of interference we call is constructive interference. So this is what we have already discussed. So also we have discussed if you have again two waves in phase and same amplitude. So I'm talking these two waves anti-phase now. So here I will write down if you have two waves, they are anti-phase. So I will write down here two waves, they are anti-phase and same amplitude. So they have the same amplitude. So I will just write down here for you. Same amplitude. So let's say we have another wave. So another wave is like this. They have same amplitude but anti-phase. So we will get line like this. Means no light. So I will simply say we get no light. So we also give name to this one. We call this is bright fringe. So we call this is bright fringe. So in this case, we call this one is bright fringe. So this is what we have understood. Now, what question is asking you? The question is telling you is that now the intensity is now reduced. Intensity of one wave is reduced. The light through one slit is reduced. So what it means actually? This simply means that now you have one wave like this has a bigger amplitude. And the other one, this one actually has the same amplitude like this, but bigger than the other one. So let me write down here. So it has same amplitude as this one. But the second wave, it has smaller amplitude, is like this now. Now, in this case, if you add these two, so what we will get? We will get bright fringe, but that will be less brighter. So this will be less brighter because you see amplitude is smaller than this one. So this will be less brighter. So we will say one thing, it will be less brighter. Now, this is for constructive interference. So it means the bright fringes will be less brighter. So we will say the bright fringes in this case will be less brighter. So the bright fringes will be less brighter. This is. The second case is what is happening to dark fringes now. So again, we have one side, it has the same amplitude as the previous one, but the second one has less amplitude, is smaller one now here. Now in this case, what will happen? They will not cancel 100%. They will not cancel 100%. So still, I will just write down, you will get some light here. So you will get this much light. So now you see the dark fringe get brighter. Dark fringe is not 100% dark. It is brighter now. So dark fringe is brighter. So here please. So dark fringe become brighter. So here. Okay. Yes. So just choose 2. That's all. Yes. So any 2 are acceptable if you write. 2 are enough. That's right. But I wrote for you 4 actually. So to give you better understanding, full understanding. Okay. So if you write 2 points, that is acceptable. So to answer this question, please now. Now, how we can answer? One thing is that the fringe spacing is unchanged. Mean the distance between fringes will not change. This is one thing. No change. The second thing you have to say, the bright fringes, they get less brighter. You can also, this can be the second point. And this is the dark fringes, they become brighter. This can be the third point. And this can be the fourth one. Now there is less contrast. If you in exam, if you write only 2 points, if the question has only 2 marks, you will get 2 marks. So you can write any 2 points. So, but this is how you need to understand what is happening, what is going on. So is this one is clear? So this is the explanation actually here. This side is explanation. So you can see here. Okay, so this is the explanation on right side. Please, if this is clear to you, so you can write down, or if you want to take photo, you can take photo and just type finished. So I will go to next one. Okay, excellent. If it is clear to you, that's wonderful. So then go to next one then. So if anyone has any question, you can type. Otherwise, I will move on to next one. Okay, so I will clear this part. Then we will write the next one. Okay, now here please. Now try to answer this one. This is very simple. This is not very difficult one. So please try to answer this one. Kirchhoff's second law. So you have to recall this one. So you are simply, I can say, you need to remember this one. So how you will answer this question? So first write down your own answer. Okay, so let me show you the answer now. The second stage is to show the answer. I hope you have done. So let me show you the answer now. So this is the answer. So here is the answer. So what this answer is telling us, in any loop, the sum of EMFs is equal to the sum of potential difference round the loop. So it simply means that if we have, for example, this is a circuit. Let's say we have one resistor connected like this. So I can say this is one resistor. I can say, let's say this is R1. And we have an other resistor. Let's say resistor is connected like this. Or this is name of scientist. Kirchhoff's is a name of scientist who gave this law actually. This is just name of scientist. Okay, so this is name of scientist. Okay, so here please. So now you can see here, in this case, let's say we have another resistor. Let's say this resistor is R2 now. So what this one is telling us, this is EMF. And let's say if we attach a voltmeter here, let's say the reading on this voltmeter is V1. The potential difference across this resistor is V1. So if we start from any point, for example, if I take this point, if I go this way and I come back to the same point, means I form one loop. So in this loop, the sum of EMF has to be equal to this one. So in this simple loop, what we will see in any loop, so in this case, EMF will be equal to V1. So this is what this law is telling. So you have to remember this one in exam. Simply you have to write as it is. That's all. Okay, so this is Kirchhoff's second law. So let's move on to next one. I hope this is clear to you. We have discussed a lot about this one in class. So we can go to next one. Now here please. Now read this here. This is given to you. So the question is here. So the first step, here is the question. Okay, so the first step is that you have to read question. So please read this question, then I will show you the answer and then I will explain to you. So first step, read question. So read one time again. So the question is asking you, show that, means your answer must be this one. So this has to be your answer. Okay, so let me show you the answer now. If you have figured out by yourself, that's wonderful. If you're still trying to answer, you can follow me and we can work together. So let me show you the answer first of all. So the answer is this. So you can see this is the answer. This is the answer. So question 5A was previous one. Okay, no problem. So 5A you have to remember. Jim, no worries. That one you have to remember. Okay. So do you want me to go back? That is just Kirchhoff's law. You need to remember what is Kirchhoff's second law. Okay, if that one is problem for you, I can go back, but that is quite straightforward. Jim, so do you want me to go back to part A or I continue part B? Okay, so part A, if you are not clear. Okay, so I continue part B. Yes. Okay, so please part B now you need to understand is that the question is asking you, the question is simply asking you, oh, this chart, no problem. I will explain to you, no problem. Okay, no problem. So I will no problem. I will explain to you. It will be very clear to you. Don't worry about that. So please now let me explain to you this one now. You see, we have two light bulb here now. So we have bulb A. You can see this is bulb A. This is bulb A. And this one is bulb B. So pay attention to this one. You will be very clear. It will be not a problem for you now. Just focus on this. Okay, now please, you need to understand, we have, this is bulb A, this is bulb B. So the voltage across V, bulb A, has to be equal to voltage across bulb B. Is this point is clear? So why this has to be equal? Because they are connected in parallel. So the potential difference across them has to be the same. Okay, this is first thing we need to understand. Okay, so this is first thing we need to understand. Now, it is also given to you, if you read the question, it is given to you the potential difference across the battery terminals is 6 volt. So this is 6 volt. Means that if you attach a voltmeter here, I attach voltmeter here across these two terminals here. So what I will read from here, I will read that will be 6 volts. So this is your battery. This is your full battery. This is if I want to draw the shape of the battery. So battery will look like this one. This is the physical appearance of your battery like this. You can see here, this is like this. This is just battery actually. If you connect voltmeter across this, you will see it is equal to 6 volt. Now it means that VA and VB also equal to 6 volt. So it doesn't matter. I attach voltmeter here and here, or I attach voltmeter here and here. I will get the 6 volt. Okay, if this point is clear, we will get 6 volt. If this point is clear to you, now you can see on this graph what is given to us. On y-axis, current is given to us, and on x-axis, voltage is given to us. V is given to us. Now, when the V is 6, I can just draw the line here. So if I draw the line when V is 6, how much current is passing through lamp A? So current passing through lamp A is equal to 0.14 amps. So you see I just connected from y-axis. And for bulb B, current is this one, this much. Okay, so what it means? It means current passing through IA current, for example, this is equal to 0.14 amps. And current passing through this one, that is equal to IB, and that is equal to 0.26 amps. Now, how much is the total current? For example, this is what question is asking you. What is value of I? What is I? So I, you will simply say that I has to be equal to IA plus IB. So in this case, we have IA that is 0.14 and IB is equal to 0.26. So we will get that is 0.4 amps. That's all. Jim, is it clear to you now how to read the graph? You see y-axis is current and x-axis is volt. So we understand these two bulbs, they have the same voltage because they are connected in parallel. So that voltage is equal to 6 volt because it is given to you. The potential across these two terminals equal to 6 volt. and then 6 volt, we draw this one line and it meet or we can intersect here. So this is current you can find from y-axis and you can find current for B from y-axis. So this is how we can answer. Okay, excellent. If it is clear to you, let's move on to next one. So I hope this is clear to you. Let's move on to next. So it's a straightforward we can answer. Just you need to understand how to read this graph, that's all. Okay. Next one please, here. So this is our next question now. So this is our next question. So I have to write down here for you. In the previous question, we have found that I current in the circuit that is equal to 0.4 amps. So this is what we have found. Now please read question over first step. First step is read question. So take time. Okay, excellent. So that's fine. That's fine, please. So read question now, please. First step, read question. Second step, I will show you the answer, then I will explain to you. Okay, so read question, please. Take time, try to understand question. If you have any question about this question statement, just type, I will explain that part. So this is asking you simply, you need to find internal resistance of the battery. So you need to find internal resistance of the battery. So we need to find what is value of this small r. So you see small r. This is internal resistance. Okay, so our stage 1 is read question. Okay, so let me show you the answer and then we work together. Otherwise, if you want to work together, first we can work together. Anyway, this is the same. Okay, so here is a second step. Answer here you can see, but it's little bit not easy to see. So let me first of all explain to you. Okay, now please, this is asking you, in this question you see, we have a battery. Battery has its own internal resistance. Battery has its own internal resistance. And the potential difference across terminals that is also given to us, that is equal to 6 volt. So if you recall, in this case, we can say in any loop, the voltage EMF has to be equal to the terminal potential difference plus it has to be equal to V lost. It has to be equal to V lost. So VT, for example, let me write down here what I mean VT. VT, what I'm saying is that this is called terminal potential difference. If you recall concepts, I have explained to you what is terminal potential difference. Means if you connect your voltmeter here across the terminals of the battery, so what you will read, that is terminal potential difference. So this is VT. So in this case, VT is given to us, that is equal to 6 volt. I will simply write down that is equal to 6 volt. And EMF is also given. So EMF is equal to 6.8 volt. I will just write down here. VT is given. VT is equal to 6 and plus you can see V lost. So V lost is equal to I times R. A small r. So this is the internal resistance. So I will simply say this is small r. So I will just write down here. So this is equal to capital I times small r. And capital I is the total current in the circuit that is given here. So we can just rearrange. So R will be equal to 6.8 minus 6 divided by I. So I is equal to 0.4. So I will just write down directly here. So now if we solve this one, you will get this is 0.8 and this is divided by 0.4. If we divide, we will get 2. So it is 2.0 means up to 2 SF, 2 significant figure. So we can write down this is 2.0 ohms. That's all. Okay, so this is how we can answer this one. Okay, let's move on to next one now. Okay, so is this one is clear how we answer this one? Okay, so let's try to answer next question now. Next one here. Determine the ratio. Resistance of lamp A divided by resistance of lamp B. So for this one, please, we need to understand is that for this question, we need to understand is we have lamp A, we have lamp B. Okay, excellent, excellent. If you did right, that's wonderful. So here now let me explain to you how to answer this one. So we have lamp A and lamp B. As I mentioned before, voltage across A has to be equal to voltage across B. So I will write down here the voltage across A has to be equal to voltage across B. So again, then I can write down IA times RA. V is equal to IR by Ohm's law. So here we have IB and this is RB. So what we need to find the ratio between resistance of A and resistance of B. So we need to find out RA divided by RB. So you see this is. Now in this case here you will get this has to be IB divided by IA here. Now you can see IB. What is IB? If you remember, we have found IB that was equal to 0.26. We have found in the previous question, and IA was 0.14. So these values we have found before in the last part actually. Now what we need to do is we just need to divide. So if we divide this one, we will get this is about 1.86. That's all. It has no units because it is a ratio between two same quantities. So this is our final answer. Okay, please check this one. If you have any questions until now, just type here. I will answer your question, then I will go to next one. Please, any questions? Okay, so is it clear? So, okay, that's good. That's good. Okay, so let's go to next one now. Okay, next one. So, okay, here please. Now, this question is asking you the total power, please. The first step again. Read question first by yourself. So the step 1, stage 1, read question. So please read question first by yourself. Okay, you have 2 minutes. So please read question and try to figure out by yourself. So you have 2 minutes. Okay, so let's work together. If you have done, it's wonderful. I square R. Yes, but but total resistance is not given to you. So you cannot use here. So it will be too long if you find first of all resistance. But there is a shortcut way also available. You can do like this, is possible. But there is a shortcut way you can answer. Let's go and try to answer with that one. Okay, with I square R, it will be long actually. Okay, so let's try to answer the easiest way and the straightforward way, because the resistance of, we don't know what is RA and we don't know what is RB, so it will be quite long actually to use this formula. So it will be quite long. Of course we can find power, but it will be long process. Let me explain to you with one simple one so we can understand. Total power produced. So total power produced, so by the battery. So you see, by the battery. So total power produced by the battery. So this is little bit helpful for you, is telling you by the battery. So now total power produced by the battery. So I can say P produced. Okay, so I will simply say P produced, or an other way of saying this one is, I can say the P in, total input, P in, input. Now please, if you recall your memory, you will see that I have explained to you that P is equal to VI and P is also equal to V square over R, and P is also equal to I square R. Now, in this case, for example, we need to find the power produced by the battery. So I can simply say it has to be VI. So the V here has to be the EMF of the battery. So this is EMF of the battery, and this is the total current in the circuit. So what is the EMF of the battery? That is given to you, that is equal to 6.8 volts. And total current in the battery we have found that was 0.4 amps. And this is what you need to do. You just need to multiply and you will get your answer. That's all. P is equal to VI. That's all. We are talking about the power produced by battery. We have to use EMF of the battery and total current in the circuit. Okay, we just multiply when we will get the answer. So that will be our answer. So in this case, answer is we have 6.8 multiplied by 0.4. So this is 2.72. So you will get 2.72 watts. That's all. Yes, this is straightforward. So please, you have to look at all possible options. Among all the options, there is always one, the easiest way. Okay, so you have to look at different options, then choose the right one. Okay, let's try to answer this one now. Efficiency we have to find now. So efficiency, how we can find out? So first thing we need to understand, what is efficiency? Efficiency can be defined in a different ways. We can say that this is energy output. So one way to define, we say energy output, or we can say output energy, or we can say energy output, doesn't matter. So we can simply say this is energy output divided by input energy. Okay, input energy. So this is energy output divided by input energy. So we can also say that power input, or you can say input power. So we can say input power. This is actually what I wanted to write output, but I wrote input. So this is the output power. We can also say that. So the output power divided by input power. So we can say divided by power input or input power. So this is how we can write down. Okay. Now, what is output power? We didn't calculate it yet, so I will calculate right now. So the input power is this one. So we have input total by the battery, that is 2.72. So what is the output now? The output, for example, you see out of the battery, the voltage we have is only 6 volt and is 6 volt. So the output will be, I will write down P out. P out, now we will find out, that is equal to VI again. So V in this case is 6 divided by multiplied by total current, that is 0.4. So that will give us P out. So in this case we have 6 multiplied by 0.4, so we will get 2.4. so this is 2.4 watts. So this is over 2.4 watts. Okay, so output means the output potential difference, the output terminal potential difference multiplied by total current in the circuit. So this is what you will get. And if we solve this one, our answer will be 0.88. Or if you want to write down percentage, so the percentage efficiency will be equal to 88%. So it means 88% energy is converted into, is used actually in the circuit, but 12% is just wasted inside battery. So this is how we can answer. Okay, please look at this one. If this is clear to you, is wonderful. If you have any question, just let me know. Okay, so please check this one, read this one if you are clear, or if you have any question, just type. Okay, so you can write down or you can take photo of this and later you can write down. Okay, no problem. So you can write down, no problem. And if you have any questions, please just type and I will answer your questions.